Okay, let's get right into this. We're going to be sketching the function k of x equals 3x cubed plus 7x squared plus 3x minus 1. So first thing we got to do is we got to find our intercepts. So you can immediately see that when you set x equal to 0, that you're going to get -1 as your output. So our y-intercept is at 0, -1. Then we have to find our x-intercepts. So you're going to plug in your numbers, right? A whole factor theorem sort of thing. And luckily for us, it's one of the first ones. K of -1 equals 0. So x plus 1 is a factor. That's awesome for us because we're now going to start our factoring process, right? This is some advanced functions type stuff, so I'm not really going to explain how to do it. I'm just going to assume that you know how to do your synthetic factoring. Oh, that's not supposed to be there. That's supposed to be a 1, a -1 actually. Perfect. So you bring down your 3. You then multiply it by your thing, add it, multiply, add. Perfect. And so you should always get 0 when you're doing this with a factor. So we can factor the original equation into x plus 1 times 3x squared plus 4x minus 1, right? And so to find what our x's are, we're going to have to further break this down, which you would do using the quadratic formula. I'm not going to do it here for the sake of time, but because it's just some number crunching. But when you do that, you get 2 outputs for x. So you get x equals approximately 0.22, and your second x that you'll get is x equals approximately -1.55. And obviously from this equation, we know that x equals -1. So that's where our x-intercepts are. Let's just write that down. So -1, 0, that's one of our x-intercepts. 0.220, and our last x-intercept at -1.550. Perfect. So now we know where all of our intercepts are. The next thing you do is you'd normally check for asymptotes, but since you can clearly look at this equation and tell that there aren't any, we don't have to do that. There are none. Next thing we have to do is we have to find our critical points. So how you do that is you set k prime of x equal to 0. So let's do that. And this is because of how the tangent works, right? Oh, let me switch to math editor, because it basically tells you where the graph is going from increasing to decreasing or vice versa. So that's where your critical points are. Apologies for that. So we're then going to plug this back into the quadratic formula because we can see that this is a quadratic function. So again, more number crunching. You can do this at home if you'd like, but you'll get that x is equal to approximately -0.26. Again, these are all approximate values, just keep that in mind. And the second x that you'll get is equal to approximately -1.3. Awesome. Now we need to find out where these points are on the actual function. So we plug them back in, these x values, into the actual function. So let's do that. K of -0.26 is equal to approximately -1.36. And if we do that for the other k value, or other x value, so k of -1.3 is equal to approximately 0.34. So now we know where our critical points are. We have critical points at -0.26, -1.36, and at -1.3, 0.34. So these are where our two critical points are at. You then have to do the concavity check, which is done using the second derivative. So let's plug in our points, negative 0.26, and we get that's equal to about 9.32. So this is concave up, right, as it's greater than 0, and thus a local min, right? Then we do that for the other one of negative 1.3, and we get that's equal to approximately negative 9.4, right? And since this is less than 0, this is concave down, down, so it's a local max. Awesome. Final thing we have to do is our inflection point, and so that occurs when the second derivative is equal to 0. So let's do that. And I know it is a little bit of an unconventional form for the second derivative, but this is the only way the software that I'm using would let me input it. So we can immediately see that x is equal to negative 14 over 18, which can be simplified to negative 7 over 9. Right? And then we have to find where this inflection point is on the actual function. So we plug in our x value, right? And we get approximately negative 0.51. So we know that our inflection point is at negative 7 over 9, negative 0.51. Okay, we now have everything we need to graph this function. So let's start with our, we'll make our intercepts blue. So we have our y-intercept over here at 0, negative 1. Our first x-intercept at negative 1, 0. Our second one at 0.220. And our last one at negative 1.550. Right? Oh, it seems that these show up here. Perfect. Then we have to plot our critical points. I think I'll make them red so they stand out nicely. So our first one's at negative 0.26, negative 1.36. And so negative 0.26 is about right here, negative 1.36 is about right here. Let's stick that in. Our next point is at negative 1.3, 0.34, it's about right here. And look at that, they're both look to be local mins and local maxes. Finally, we have to plot our inflection point. So we know it's at negative 7 over 9, which is about negative 0.7, just a little bit more, so we'll put it right here. And it's at negative 0.51, which is just below the negative 0.5 mark on our graph. So that's about where that is. Okay, now that we have that, let's draw our line that connects them. So I think I'll use a nice little teal color. Let's see how this looks. Apologies for my poor drawing skills, but actually that came out pretty nicely. So we've finished graphing this graph. For a little bit of, if you want to make it a little bit nicer, you want to add your points directly on. So let's do that. We'll just do this for the key points, not the intercepts, because those are kind of implied where they are, and it's kind of easy to find them. So that's our inflection point. Here is one of our critical points right here. Let's make that look nicer. And our last critical point, which is at negative 0.26, negative 1.36. And just like that, we've graphed this function k of x equals 3x cubed plus 7x squared plus 3x minus 1. You can plug this into Desmos to confirm that this is what the graph actually looks like. Thanks for joining me. I hope you learned how to do some curve sketching and how to curve functions. Thank you.